Olá, estamos aqui no 10º Congresso Brasileiro de Melhoramento de Plantas em Águas de Lindóia, interior de São Paulo. Pesquisadores, estudantes, professores e diversos profissionais da área estão tendo a excelente oportunidade de assistir palestras sobre melhoramento de plantas e interagir com pesquisadores nacionais e internacionais que estão trabalhando com o que tem de mais moderno em melhoramento e outras áreas relacionadas. Nós, do GVENCK, o Grupo de Extensão em Genética e Melhoramento de Plantas da Exalc-USP, com o apoio da Sociedade Brasileira de Melhoramento de Plantas e do GENT, que é o Grupo de Divulgação Científica da Exalc-USP, fizemos algumas entrevistas com os palestrantes presentes aqui no evento. Os entrevistados de hoje participaram do Smart Tool for Plant Breeding, uma série de palestras com renomados pesquisadores internacionais com o apoio da Corteva AgriScience e o suporte da Sociedade Brasileira de Melhoramento de Plantas. Estamos aqui com o pesquisador Charlie Messina, da Corteva AgriScience dos Estados Unidos. Hi, Dr. Messina. Welcome to Brazil. Thank you for accepting our invitation. It's really a pleasure to have you here. So, can we start?
Absolutely. Thank you very much for the invitation.
At first, could you please talk a little bit about yourself, like your career as a researcher, and how have you become a researcher at Corteva?
Maybe we start how I became a scientist at Corteva and why and what I'm doing later. Maybe switch a little bit the order. Mm-hmm. The how is probably as many other students. I met Tabaré when I finished my PhD, and I learned that we have quite a few common interests, scientific interests with Mark Cooper. And of course Tabaré was part of that team at the time. So how I got involved in Corteva? Through Tabaré. So everybody who knows Tabaré, just take advantage because those are the opportunities that will bring to students. The why perhaps is it's more important. I was finishing my PhD and the scientific questions I had, they overlap quite a lot with Mark's Cooper's interest and Graham Hammer. So that's from a scientific perspective. And the other piece is Corteva brought unique opportunities to answer some of those questions in two regards. The opportunities in terms of resources, human resources. Again, there was a very diverse community of scientists with whom we can interact to help advance the science. But on the other hand, Corteva does business in 70 countries or more, and that creates tremendous opportunities for the science we do to translate that into technology that will affect the lives of growers in a positive way, from consumers in a positive way, and do it in a planet-friendly manner. So it was a way to do science and at the same time have a tremendous impact on human lives. Positive, of course.
Talking about your main research lines, how they can reflect in plant breeding programs nowadays?
We connect that with a little bit about what we do in my group. I started as a research associate. It's not a position that most of the PhDs seeks to do. It seems to be a little bit lower, but you can progress. And we start in that position developing some of the models that we are using today with Mark, and you can progress to scientist and distinguished fellows now. And this is in part reflecting the tremendous team that I have the pleasure to work with. So this team, what it does, first is fairly diverse from life histories to scientific competencies, and we do predictive models. In the end, one component is the crop growth models, but then there's a genomic prediction, cropping systems, as a set of tools that we seek to accelerate genetic gain. So how it relates my research is doing predictive models to improve the efficiency and the size, if you will, virtual breeding programs, and how to position those products in fields so farmers are more productive.
Interesting. How do you think that an event like the 10th Brazilian Congress of Plant Breeding can impact in the future of the Brazilian agriculture?
That's a very easy answer. First is through, if you will, a human dimension, right? Students will get ideas, to progress their research. Students and professors will meet others. For example, they can create opportunities to go visiting scientists in other universities, advance the technologies that they will be utilized to improve genetic gain in breeding programs. And for some of us who are just visiting here in Brazil and work in the US, is to connect with others, to advance methods. We have one example with University of Illinois and Queensland, that we can think about advancing the models and the frameworks we are thinking about breeding. But think about Corteva, for example. We do lots of breeding in Brazil. So we can start applying some technologies that we develop in the US for US agriculture now in Mato Grosso. So again, this conference, we have a direct impact on the efficiency of the breeding programs in Brazil, and that will bring economic benefit to the Brazilian agriculture. So those are examples that come to mind right now, but there may be many more.
Good. In your opinion, what are the perspectives of genetics and plant breeding in the next years?
I think prediction will be key. One way to increase the size of the breeding programs is through prediction. We demonstrated that with the creation of the Aquamax product. There are 20% pretty much of the US agriculture using these products that they were created using molecular breeding technologies. Again, instead of increasing more plots and put more combines and whatnot, I think the focus will be on generating high quality data, collect the right data, use high throughput phenotyping methodologies to understand the biological system, to have an unprecedented understanding of genetic variation for adaptive traits, but the prediction component using, if you will, genetic information is the one that will enable us to scale the breeding programs to accelerate genetic gain. Again, this population size and diversity that will harness in order to drive progress. So quantitative and mathematical predictions will be key.
And what are the main advances in the use of crop growth models combined with genomic selection, rather than just genomic selection? And why is it considered a more biological approach?
Think about the sort of crop science as a discipline that underpin all the breakthrough technologies in agriculture. And crop science have a number of elements. One is genetics. So thinking about crop models more biological is probably not accurate way of doing it. But you can certainly harness more biological understanding by bringing physiology, which is another discipline of crop science, and crop ecology, which is another discipline of crop science. So the more biological it perhaps reflects on the number of disciplines within crop science that you are layering or harnessing together in order to increase the predictive skill of these genomic selections. It's not replacing them. If you think about genomic selection as we is today, is virtually leveraging sort of the G component of the G by E by M equation, right? So the crop growth model will enable you is to take that basic and that foundation of that infinitesimal model to drive processes to simulate how the plant will behave. So essentially a crop growth model encapsulates a lot of physiology and ecology and soil science and put that to the service of the geneticist. Well, the geneticist can provide some service to help the agronomists figure out what sort of hybrids they need to put where and how to manage them. So the advantage is now you are utilizing more scientific knowledge to make predictions. If you want to think from a mathematical abstract concept, the crop growth model is one element of that sort of machine learning. It's a supervisor, right? So it helps the genomic prediction now deal with some of the environmental and management contexts. Well, it helps the genomic prediction model G by E by M, which otherwise is not, the equations are not there in the genomic selection algorithms as we know it today. Again, there may be other ways, but the biological ways, by encapsulating biological knowledge and using scientific principles, you're protecting yourself from making mistakes as you make predictions about the systems in the future.
Very good. Thank you for your answers in the great interview. Essa foi a entrevista então com o Dr. Messina. Aproveitem para acessar nossas redes sociais para ver outras atividades do nosso evento aqui no Congresso de Melhoramento de Plantas e também no YouTube para ver outras atividades do nosso grupo GVENCK. Obrigada.